The way we design, build, and operate buildings is undergoing a radical transformation. Welcome to ACE IoT Flight Logs. I'm Andrew Rodgers, co-founder of ACE IoT Solutions, and I've spent years immersed in the world of smart building technology. Join me as I learn from the industry's leading innovators, researchers, engineers, technicians, and more, how we can revolutionize the entire life cycle of the built environment. Get ready to take flight and explore the future of how buildings are delivered and operated. Hey folks, Andrew Rodgers here with ACE IoT Solutions. Today we're going to be looking at a project that ACE undertook with Dartmouth College for the last 6 or 8 months, looking at better managing and better visibility for BACnet networks in large campuses. If you talk to anyone in this industry, you'll hear complaints at some point about BACnet networks having broadcast storms, duplicate device IDs, like a number of issues, especially when you're talking about a larger campus like Dartmouth where you have multiple vendors with different OEM platforms trying to manage their devices in the same network. And those OEM tools don't always provide the same kind of first-class support tools for third-party devices that they do for their own. And so when you get all those mixed together, sometimes the facilities team can feel a little in the dark. And that's where Dartmouth was. So with me is Doug Plumley. Doug is a software architect for the campus services at Dartmouth and has been helping their facilities team learn and figure out how to manage these technical challenges better. Doug, tell me a little bit about what you do at Dartmouth.
So I'm a software architect. I kind of run the gamut of working on just hard, IT infrastructure, like applications, software, but also get into the realm of writing code, automation, and more recently, over the last few years, we've been getting involved with our building automation systems and specifically the BACnet networks and how we manage them. We get pulled in for several reasons, but one of which is just due to integration issues that we were having between building automation systems and lighting systems that were having kind of a real negative carbon impact for the college. So by focusing on those, we're able to net some really nice energy savings because integrations that were planned to be working are working. We're able to implement those integrations much faster and with a lot higher success rate.
I think one of the things that we were very excited at ACE to work on Grasshopper with Dartmouth, we have kind of over the years deploying in many customer sites, we've recognized that there's a disconnect between what people think they buy and what they actually bought. And it's rarely evaluated until they go to deploy the next phase of their smart campus or the next phase of applications for decarbonization, for occupancy, for air quality, whatever that next application is after they've built the building. And they think they've specified everything they need to just make that seamless. And then they never find out that they didn't get what they thought they got until that very moment. So is that something that Dartmouth had some experience with as well?
Yeah, so we have some very public decarbonization goals. We're making some substantial changes to our district heating and cooling system, bringing in geothermal, and we're building buildings and renovating buildings kind of in conjunction with that. So we're moving to a lower temperature hot water in that district. And so there's a substantial amount of equipment change that has to go on in the building to make that a reality, essentially. And so with that, a lot of updates to our control systems, integration between systems to really squeeze out every efficiency that we can. And so we're building, in a lot of cases, complicated buildings that have a lot of dependencies between these 2 systems or 3 systems or 4 systems. And when things don't work, well, we don't get the performance that we paid for. And so we're able to demonstrate that with some of the tools that we have in place, like our campus energy management system. It's able to find insights that we can action. And in a lot of cases, it's able to show by making these integrations work and by focusing on BACnet and the reliability of BACnet, there's like a net cost savings and then, a substantial carbon savings as well.
So one of the things we're really excited about Grasshopper and then our product version of it, Sentinel, kind of application spaces, is that we get into a lot of projects where facility owners and managers are deploying a new application onto their building automation system, onto their lighting control system, demand response, peak demand limiting, whatever those more advanced supervisory control use cases. And they have great facilities folks. They have an amazing technical team. They hired all the right consultants. They wrote the specs the way they should write them. They had all the technology infrastructure in the specifications. But when we go to deploy the application, that's the first time a third party has evaluated whether they got what they specified. And it's not even necessarily that the vendors are saying, we're not going to give you what we said we're going to give you. They don't have tools to validate it either. So we think that Grasshopper and Sentinel are great tools for folks who want to validate that they're getting the interoperability that they're specifying when they're commissioning these projects. Is that a use case that you see at Dartmouth?
Absolutely. I think the challenge is the scale, and to your point, the lack of tooling to enable humans to reason about that scale. And so what we're finding is with Grasshopper in place, whether it's Grasshopper or Sentinel is irrelevant, having essentially a network graph and a visualization that goes with that graph lets us, look at things and see obvious defects, let's say. But it also is kind of a foundation to evaluate, I have a large capital project. These are the things that everyone agreed upon would be there when this project is done. Do these things exist from a BACnet perspective? And so the visualization just is immediately helpful for that. We could simply layer on additional controls on top of that, or the graph specifically, to do some of that evaluation for us. So it's not people combing through visuals or combing through logs to try to find these things that are not working that we all agreed that we were going to build. It's systems evaluating, this is the criteria, this is what was supposed to be built. Did it get built, and is it represented digitally via BACnet?
I think it's a really exciting use case. I'm 100% with you on the tooling and having automated tools to do this. That's why we built Grasshopper the way we did, with a robust graph-based data model in the back end that is standards compliant and can interact with other knowledge graphs. But I've also been amazed at how a visual representation of a network makes the problem so obvious. I think you have kind of an example pulled up here right now, Doug. A common problem in a BACnet network, duplicate device IDs or duplicate network numbers. Yeah, what's going on here?
Yeah, so I think what we have highlighted here is, it's actually kind of an interesting artifact, right? So if you look at any of these kind of other blobs, we have networks with a lot of devices attached to those networks. And here we have kind of some devices off in the corner here, hanging off a network, kind of dissimilar from all these other things. So what I would say is that we have some devices we have some duplicate devices, right? So we have devices that are essentially appearing on more than one network when they shouldn't.
So likely that network is somewhere else, probably on a different building, probably on a completely somewhere else, but it has some device IDs that are superimposed on a network that's a valid network. Interesting.
Yeah, and then further down, it looks like we have a network that is being routed by more than one IP router.
On all these things could, if you're in the HVAC system and these devices are in the lighting system and you're trying to pull in occupancy from lighting devices that you may not have full administrative view on the OEM's platform, it could be really frustrating and really hard to diagnose some of these challenges, because you're sending object property request for a point is on that device, and it's saying, I don't have that point. And you're like, well, what? But it's not even the device you thought it was, because of these kinds of non-deterministic routing.
To layer onto that, what's even more frustrating is when these things are non-deterministic, that means that sometimes you're seeing it as an intermittent issue. And so without this kind of 10,000 foot view, this visibility, essentially what you have is, you get called in, something's going wrong, you're looking at it, and then, maybe by the time you get there, it's already working. Or maybe you can't reproduce it. And then so you have to resort to more and more impactful measures to figure out what's going on. Maybe
the old, we're just going to unplug it for a few days.
We're going to unplug it for a few days. We're going to, split a bus and take a Wireshark on, this daisy chain, and, the impacts that kind of has to the downstream things. And then just the act of using Wireshark itself.
Yeah. So you brought up Wireshark, and I think you and I are probably very familiar with Wireshark. You can diagnose just about anything with Wireshark, but the technical barrier to entry to Wireshark is pretty high. There's an assumption of a lot of understanding of a lot of technical concepts. Like if you are an average facility manager and someone hands you a packet capture, even if you have good support from your IT team that they can go get packet captures off remote networks for you, do all that stuff, and they hand you a packet capture, there's a lot of expertise involved in looking at those packets and understanding the root cause of those problems. And I'm hopeful that, and the other problem, of course, is knowing where to do the packet capture at. So, in a lot of cases, if you don't have that sort of robust campus, enterprise network background or infrastructure for your BACnet network, you're sending a technician out somewhere with a laptop, port mirroring, to capture those packets. And, that's expensive. That's time they could be resolving hot cold calls. There's all kinds of better ways to spend a person. They could be fixing a VAV somewhere. There's all kinds of better ways to spend that person's time. And then you don't even know you're sending them the right person, the right place in the network necessarily. And I think one of the things that Grasshopper really helps with is at least evaluate, like, we know there's a problem on this network. Like, we can see these duplicate routers. We know exactly where to go for that.
For what's really helpful for me, echoing what you've said, is a point-in-time snapshot of the state of your network. So I think most organizations that would add this into their network and start monitoring it, and monitoring it in a more active way than a passive way, you're going to immediately find some things that you didn't even realize were there. But even for us now, having used this for months, we still find things. And it's still helpful to kind of know yesterday what the state is and today what the state is, and having the ability to temporally compare them, run the differences between them and have it shown visually. And you can kind of see that here. Right? So in some instances, issues that are issues today were not issues yesterday, and in kind of in an environment like ours, where there's massive amount of capital investment, many projects, and even setting those aside for a moment, just the general maintenance of controllers. A building that we renovated 10 years ago might need controller updates today. So things are constantly changing, and the level of coordination you would need between humans to know what's exactly changed is just incredible. So BACnet kind of levelizes that for us in a way that, we, one, require it, and two, we kind of generally know what the representation of a thing on the network is going to be from a BACnet perspective. And so with that in mind, when we have the ability to diff two captures, two states of the network, and show it visually, we can kind of start reasoning about, all right, we have an issue today that wasn't there yesterday. What changed? And so in this case, we're showing a network that is being routed by two routers, and we can kind of see which router is the new one, right? And that's resolved a lot of finger pointing for us, because now we have a tool that essentially says, all right, it's first come, first serve. We recognize that sometimes things get missed, or people have fumbled entering data. We just need to know who wins and who needs to move on and change their configuration. And so this just immediately eliminates all of that, because before it was very manual.
And so you can go back and look at exactly what sort of work orders were in your system on the day that this change was executed, and know who was doing what where, and immediately identify, down to a few at least work orders, like, hey, this is probably where this happened at.
Yeah, so we have the ability to select a graph from a point in time. That gives you the state of the network. We can also run comparisons between multiple graphs, and this essentially gets spit off into a queue, which gets processed and essentially is running the diff between the two. Once that's completed, now we have this ability to go in here and select a comparison.
It's a pretty decent sized data set when you start adding in all these devices from all these networks. And there are other data models besides graphs that might be more performant, but the graph is really what allows us to do these very discrete analysis, like what's the difference between yesterday and today, and it's a very known computational problem to solve that, and you get a very clear result. Whereas if it was a more arbitrary application language, domain data model, then anytime we added a feature to the graph, we'd have to figure out how to differentiate those features between different days and all that. But because it is this graph under the hood, this knowledge graph, that's all very well solved computer science. And it's really cool that we can leverage that level of technology on this.
I like to think that as friends are helpful to BAS engineers, graphs, especially ones that we can analyze temporally, are helpful to BACnet nerds, BACnet engineers. And so, we want to store the values of things over time because that lets us look back and forth and see how things have changed. And Grasshopper is essentially that. It's just in a different format. It's more complex, but it lets you reason about the network and the changes to the network in a way that substantially shortens the time to fix issues with the network.
So Doug, another place where we think Grasshopper and Sentinel can be really helpful is in environments where your facilities and your IT teams sometimes struggle to communicate. I know from my experience coming from the technology side over to BACnet, there were a lot of things about BACnet that they don't line up well with how we think of networks and applications running typically in our environment. Most of the world uses TCP. It's a very, specialized sort of esoteric knowledge set. So when you're describing things to an IT team, sometimes we've witnessed a lot facilities and IT teams talking past each other because for the IT team, the network stops at the switch port, and for the facilities team, that's where it gets started with MSTP trunks and ArcNet still in a lot of buildings. So we see Grasshopper Sentinel being a really effective tool just for helping teams communicate, with a common language. Have you seen that use case play out at Dartmouth?
Yes, I think there's always this IT versus OT mentality. I would say that's a solved problem at Dartmouth, but it is still prevalent in a lot of organizations, especially large organizations where you have teams dedicated to, as your point, up until the switchboard and then from the switchboard on. And so it's both a technical divide and a business divide in some cases. What Grasshopper lets you do is you have a conversation piece, right? So there's artifacts from kind of both of our worlds. The serial networks are represented with their devices. The routers that make those serial networks available to the IP networks are there as well. And so kind of you have both languages, if you will, in one visual. And you can point to things and talk about them rather than an OT person talking to an IT person about something they've never heard about, a protocol that really, from an IT perspective, is very alien, is very foreign. You now have the ability to point at something and reason about it with them. And so it can take some difficult conversations Like, why do we need to have BBMDs, and why do we need to rebroadcast things between VLANs and subnets and simplify them? Because you can say, I have a device over here and I have a device over here, and they are in different parts of the campus, but the data from one is important to another, and I need to make it available there. And a BBMD isn't necessarily a requirement for that, but it does exist in that kind of backnet application stack, and it enables a lot of tools that just work.
Yeah.
So that visual is very important.
Yeah. I think it's really fascinating. Like, no one in the facilities space, no one in BACnet talks about service discovery. But that's literally what like 90% of the value of BACnet is. And it's so funny like how it took so long for IT, not kind of. Service discovery in IT is a pain in the ass. Like, it has been for a long time. And like Kubernetes kind of, when people built Kubernetes, they rebuilt a bunch of it from the ground up because it was so complicated to try to like make it work at scale in a Kubernetes cluster in a like very seamless way. So that's why we have like 4 or 5 different pluggable service discovery layers for Kubernetes at this point, maybe more, probably like 10. But it's interesting that for BACnet, like service discovery was like built into the protocol from day one in a much more robust way than DNS, in that like DNS is great if you know what you're looking for, but with BACnet you can literally say like, who has a point like this, and a bunch of stuff will tell you they have points like that. I honestly think it's bad practice to use it. I don't think you should be like building control systems that are just like using those tools, because I think like you said, when you get to the size of a campus like Dartmouth, the broadcast domains being that large start to become problematic no matter how well managed your network is. And so, but it's still cool. Like, it's cool that it was solved 30 years ago.
Oh, and when you say service discovery, my brain immediately goes to all the things that we take for granted on a day-to-day basis in our homes, maybe in our places of business. If you're an Apple user, your ability to use AirPlay and not have to find out where on the network this thing that you're trying to cast to is.
But that
happens.
Stuff is like, that stuff is recent. Like, it's
yes.
AirPlay becoming like seamless is in the last 10 years. And like, for a long time, networks didn't support MDNS. Like, it was rough for a long time. Service discovery is still one of like the most novel, I guess, like spaces in this infrastructure that we use. Like, yeah.
And in an IT network,
funny.
it is one of the first things that gets shut off, right? So we take for granted the things that we can do at home. I want to add a printer to my computer, and it's just magically there. I don't need to know the IP. With the AirPlay example, things just work. In an enterprise network, that doesn't necessarily scale. And a lot of IT teams, rightfully so, will turn these things off. The challenge is, you're right, BACnet has built this in from the beginning, and it does enable a ton of different use cases. So you need to work with your IT teams to kind of show them, well, these things are important not just because I say they're important. I'm going to show you why they're important.
Yeah.
Right. And I love that BACnet. It's in that application layer, right? So baked into so many of these software products that we use is that discovery. Right? I'm not doing it in one tool and then copying and pasting information to another tool. It's built into the thing that I'm doing the programming in, or doing the diagnostics in. It just exists. And for those things to work, you need to make connections between networks. And to make connections between networks, you have to be able to articulate to your IT teams why those important connections are being made in the first place, because to them, it's just risk.
I'm going to show a few things from some other sites where we have Grasshopper deployed. Luckily for Dartmouth, I think, or fortunately, they haven't experienced some of these issues. They've got a DUG. Not everywhere has a DUG. That's one of the key takeaways. Like, that's one of the things we've learned in this industry is DUG is a rare entity. We think if you're a larger campus, you need a DUG, but that's not going to be feasible for every facility that has these kinds of challenges. And we think Grasshopper and Sentinel are ways for folks to take their existing facilities management team and give them, supercharge them with some tools that they've never had before to solve some of these problems. So this is another large university campus. What's different about this graph than what we were just looking at? Obviously, fairly similar in the fact that it's a bunch of networks, probably a network in each building. The difference here is we actually are showing the links between the BBMDs connecting all these networks. So folks who know a lot about BBMDs, probably, this will be duplicative, but just really quickly reminding everyone what a BBMD is. BACnet was initially kind of, the protocol was oriented around a single broadcast domain. And as networking practices morphed and improved, I think, we found that it was much easier to manage a lot of smaller broadcast domains and route them than it was to have these massive domains. But in order for the service discovery feature in BACnet to work well, you need to be able to get your broadcast out to an entire network. So BBMDs, BACnet broadcast management devices, will sit on a subnet, a single broadcast domain. They will listen for broadcast packets, and then they will forward those broadcast packets to a list of devices that you manually configure of other BBMDs on other broadcast subnets, and they'll forward them via unicast. So they'll forward them via a routable protocol where it can go through anywhere, all your VLANs in your campus network, through your core infrastructure, however it needs to get to that other subnet. The other BBMD gets that unicast packet, and it broadcasts it on its local broadcast domain, and vice versa. It's a very simple function, but there are a lot of ways that it can go wrong. So one way is that you can just have sort of asymmetric BBMD configurations where you have a BBMD that's listening on this broadcast domain and forwarding to a BBMD on another domain, but that BBMD is not forwarding back. So that's you'll get one-way visibility in service discovery, and that'll be very confusing to troubleshoot why you can see a device from one place, but you can't see it from another. The other one, which is probably the problem that almost everyone who has managed a multi-subnet BACnet network has experienced at some time or another, is a broadcast storm. And a broadcast storm occurs when you put two BBMDs on the same subnet and configure them both with forwarding rules that land on some other BBMD. And the reason why is because they both think they're authoritative, and so they're both forwarding the same traffic via unicast. And the receiving BBMD, unless you have BBMDs with rules configured with basically access control list on their unicast inputs, doesn't differentiate between those two BBMDs sending packets, and they will just continue forwarding. They'll duplicate those broadcasts on theirs, which will then get picked up and duplicated on other broadcast domains. So you just end up with this, every packet getting duplicated and then forwarded out across your network. Sometimes we'll find those with, not just a set of duplicate BBMDs, but 2 or 3 or 4 in the network, and then you just get this massive mess where it's a logarithmic, like this broadcast domain is doubling these, and then this one doubles those, and it can very quickly crash your network. So this campus, these BBMDs are these blue icons here. This loop is actually a network edge, a graph edge. Grasshopper is an open source platform. We welcome contributions, github.com/ACE IoT Solutions/Grasshopper. But we're working on some better representation. A valid BBMD has a connection to itself. That's just kind of an idiosyncrasy of the system, the way they were built. That's how valid BBMDs work. So this edge is really just an entry in its broadcast distribution table back to itself, looped. So we see this BBMD is connected directly to a subnet. So this is the subnet it's authoritative for. And then it is forwarding traffic to 2 other BBMDs. Now, it's very unlikely that this network is performing as it should, because generally every BBMD should have an entry to every other BBMD so that traffic just gets forwarded once out through the network. And to see that this BBMD only has connections to 2 is probably indicative that there's some asymmetric communication happening here, and things probably are not working the way we would expect on a typical broadcast or a BACnet network. But the real problem is this network here. And you'll see that there's these 2 BBMDs, and I'll drag this one over, and they both have connections to this single subnet. Interestingly, this one has a reference back to this same BBMD. So I'm actually not sure what that's doing right now. Maybe because it only has this BBMD in its BDT, that this BBMD recognizes that this is a broadcast traffic for its own domain and doesn't do anything. But regardless, we know that that is not a configuration that we want in a valid BACnet network.
So earlier, Andrew, you highlighted something that is prevalent in BACnet networks, but we're actually at Dartmouth trying to not do anymore. And so in that kind of middle, you have this matrix of connections between BBMDs, and we have that. And as we've grown, especially with BACnet IP and in the future BACnet SC, maybe we'll have its own implications in this world. Maybe no BBMDs, which is nice, but those BBMD connections have resulted in a logically very flat network. And so issues, to use your duplicate BBMD example, issues that are kind of present on one network present themselves in other networks. And this can come in a lot of different forms. To use an example, we had a ongoing capital project, and we were having challenge with some controllers crashing in a building that was being built, right? So, warranty issues aside, because the thing's not even commissioned yet and it's not working. And what we found is immediately diving into the Wireshark side of things and kind of going through the ASHRAE specifications for BACnet. Well, we had a controller across campus that was sending an invalid BACnet network that the protocol stack on this other controller that was crashing was not handling. And it's really hard to construct that just looking at packets flashing by the screen in a Wireshark capture, right?
Right.
So the connections between these networks matter. And
right.
How we've articulated this to folks at Dartmouth is these things generally have broadcast domains or blast radiuses, if you will. So when things go wrong, how wide do you want that wrong thing to go? And we've been trying to reason about our networks to see actually where we can cut connections between BBMDs, which just feels like so anti the typical BACnet flow, that we've all become familiar with over the years. But it's being more diligent about saying, all right, this is a shared resource, such as a outdoor weather station, which is calibrated yearly. It's a really good reading. We want to make that data available to buildings, right? That network's going to get connected to every network. We want to make that data available globally. But building A and building B, which are not mechanically tied together and don't share data, do we need to draw that connection with BBMDs between them?
Right.
Because to go back to the example of the controller that was crashing other controllers, well, you've made a connection for no purpose, but you've essentially extended that blast radius to the 2 buildings. We're trying to be really intentional about the connections that we make, and we did not have a tool to reason about that. And asking these questions to the folks doing the programming wasn't really netting the amount of information that we would need to make good decisions. So we, faced with doing nothing or making bad decisions, we built a tool instead with your team.
How are you, what happens when you decide you need connectivity between 2 networks after you've had them segmented?
It's unfortunately come in the form of, hey, this thing is not working, and I expected it to.
Yeah.
And sometimes that's even after asking the question that should have given us the information so we would know that connection needed to be made. Right. So our early versions of this, again, was to reason about the network. And it wasn't actually for us. It was to sit down in a room with somebody and say, hey, you have things here and you have things here. And these are the buildings associated with these things. Can you point to what here needs to talk to what here? Right? It was literally, the intent was to like print this thing out and like bring it to meetings and talk to people about it. It's evolved way past that. And it's become a tool that we just are using to manage the network. But yeah, the original intent was to really start carving up the networks and using this as a conversational piece. That's another feature in this, Andrew, that I think would be worth sharing is at the bottom right of your screen, you have the ability to hide things. And so there's some ability to even, using my example, if you wanted to bring this to a meeting and maybe pretty it up a little bit and quiet down some of the noise, you can hide stuff, right? So you can hide networks, you can hide individual devices. And at the bottom left, you have a configuration which lets you control the physics and lets you control how this is rendered in the browser. It's very powerful.
So these are things that, like I said, it's very easy once you have the data model, which in Grasshopper is always available. The raw data model is available as a turtle file. That's an interoperable representation of a graph, knowledge graph. And then you also have your device or asset registry available as a CSV. So if you do want to use this for inventory or sort of more traditional just asset management, you always have that ability to just open the list of all your devices in Excel. And to Doug's point earlier, all your devices at a particular point in time. So you can pull up a asset register for a month ago before you brought this new building online in your campus, and you can pull up an asset register after that and be able to validate that all those devices are in the list that they're supposed to be and have the right naming conventions, et cetera.
Layering on to the asset piece, what's delightful to me is the only thing you have to do to make a device appear in this list is buy things that support BACnet. So as you're thinking about what you want to put in your specifications for construction, that's a really important piece. And you're kind of getting batteries included when you do things like that. What's great is that's just to get it in here, and that's just for assets. The use cases you can layer on top of having a knowledge graph like this are kind of limitless. It's really up to your imagination. That's why I like how we framed this project with your team, Andrew, and ACE IoT, is this is open source. And I think this highlights the power of open source. You can deploy this in your environment. You can make improvements to this. It's permissively licensed. And it just means it's accessible, right? So your investments into a platform like this are protected. And that's kind of the warm and fuzzy feeling that I got when we started this as a project at Dartmouth is when this is all said and done, we own this thing. And there's no perpetual licensing for us. We kind of have to run the infrastructure ourselves, and that's okay. Some people are going to want to use your commercial project, Sentinel, and they're going to let you handle the details. And that really, again, depends on what's your facility team made up of. Do you have people that can run the IoT infrastructure, or do you have people that just need to fix things? And so I love that there's the choice there.
That's a big part of ACE IoT's DNA. Our entire IDL platform is built on open source technology. We contribute a lot to the open source projects upstream, Voltron, which probably people have heard me talk about before. So we were really excited to work with it in this context as well.
The other components I really like is what you don't see here is there's an underlying REST API that's powering this experience, right? So that's, again, built on open source projects, open source standards. Great example right here. So the IT folks that are watching this, hey, there's your REST API that can help you reason about BACnet. So when I first came into this mix and was learning about BACnet, it's like, where's my API? I just need to think about how these things are constructed, and I need something that can let me deal with the scale of the issues that we're facing. And this is the tool that we didn't have at the time. But that was the motivation for building this tool and really collaborating with ACE.
That API is great because it gives you access to all these underlying graph data models in a programmatic way. So if you are, if you have a data science team somewhere who wants to plug away, if you want to integrate the data model in this graph with your building systems data model in a brick graph. You can connect those two. This is very extensible and interoperable. One of the things we're excited about is other types of data that can be layered on here. So this is about, right now, this is all about documenting your architecture, which a lot of people have never seen a map of the infrastructure they have deployed in their buildings like this, that goes all the way out to the edge devices on the serial trunks. But in the future, adding more data inputs, so integrating with platforms that say already do BACnet traffic analysis to pull in some of the insights from those tools so that you can see them layered right on your network to see where a device that has a lot of traffic might be affecting downstream applications in a particular building or on a particular subnet. Those are all things that can be just layered on. One of the things that we've built in this is we have sort of specialized classes for the edges and nodes for the BACnet concepts. There's actually an ASHRAE draft standard out right now that defines the BACnet RDF model. So that wasn't available when we started this project. We used some of the initial working group work to build this. We will align it to that standard where it's not. I'm pretty sure it's about 95% aligned right now. But the front end that we're exploring the graph and looking at all this stuff is built so that any arbitrary data you add to your graph will show up. It may not be styled in a way that's particularly consistent with something is a building or whatever, but you can add any additional metadata you want using standard RDF manipulation tools, and they'll be visible in your graph, and you can see how they relate to your communications infrastructure. And that's just back to that open extensibility, interoperability, really trying to keep that at the forefront of this project. Doug, thanks so much for spending this morning with me and talking about how Dartmouth's using Grasshopper. If folks want to see what Grasshopper or Sentinel can do on their facility, please reach out to ACE IoT Solutions. If you're a technologist and you want to play with this and see how you can help your organization better manage BACnet networks, how can people get involved, Doug?
You all have published the Grasshopper agent code to GitHub, which you're showing here. That's the place, right? So, for OT, IT enthusiasts, professionals who want to get in this thing and start hacking on it and improving it, maybe even fixing some bugs, extending the functionality, it's all here. This is permissively licensed. That was done with intent. We want to really show the power of open source software for the built environment. It's something that is sorely lacking in so many places. This is now not one of them. We all have a tool that we can use and benefit from.
Certainly, if there's something that you think would be a killer feature, you file it as an issue. Love to think about how Grasshopper could help solve more problems. We think once you have that core data model, there's just so many applications where this could be helpful, and we're really excited to see how the industry makes use of this tool that Dartmouth has so graciously made available. Thanks again, Doug, for being on. Really, really appreciate your time.
Thanks, Andrew. It's been a pleasure working with your team and you.